Hello, so this question is search suggestion systems. So you are given the array of string product and also the string search word. So what you need to do is you want to type the search word, one at a time, and then suggest products should have common prefix. So if there are more than three products with a common prefix, then you want to return a lexicographically minimum product. So let's see. So what you need to do is technically for MOUSE mouse, right? So what it does is for the M, then you will definitely just go through every single one of them and then you sort it. So what is the lexicographically order? So let's see, mobile MO. So everything start with MO. So B will come first, right? And this will be N, right? Multiple and monitor, and this is U. So you know when you type the first character, it start from M, right? And then we're going to do the ordering, and then these three words will be the first top three result when you type single N. And then when you type O, this will be exactly the same thing, right? Now when you type U, okay, because these three words, the third character is not U. So technically this is going to be like this. So what is the MOU? What are the words? So it's going to be mouse and then mouse pad. So the U will be the same, and S will be the same, E will be the same, and then later on you have what? So this is the end of the string for the mouse, and then the P will be the mouse pad, right? So that is why these two are after, and then you keep typing, right? So you type S, and this will be exactly the same output, and then you type E, this will be exactly the same output. So the idea is pretty straightforward. What we need to do is we need to build a trial. So what is trial? Trial is actually really fast. So what you need to do is you are going to build A to Z a character for each level, and then every character you will build your next children. So A will goes to A to Z children, and then in between A to Z you have BCD, and then XYZ, right? Every single one of them will build your own children, okay? Only if the next character exists in the current root, okay? So at this moment we know M will build A to Z, okay? O, so you build A to Z, but you are not using any of them, but you build O A to Z, you build U A to Z, and then so on. So you're going to build the whole entire things, and then you're going to build this, and then you are trying to iterate the product. So you iterate the product, and then you want to find out everything what you have in the trial tree, and literally just search for it, and every single level you want to sort it. If this is more than three, you want to pull the last one after you sort it, because it has to be lexicographically minimum. So let's start writing. So you have class of trial. What you need is children, and also the suggestion. So I'm going to use a linked list because at some moment of time the list will be more than 30, and then you want to pull the last one. So trial, and then I'm just declaring the variable right here. And then I will just declare my trial. I'm going to say root equal to new trial, and then I traverse the product. Then after this I can start inserting into my root. Okay, and then once I insert the whole entire things, I can search for this, right? Because when I search for this, I'm going to return the 2D array. I mean list of lists. So return search root, and then what you need to search for is from the search word. So you build your own trial tree from the product, and then you iterate the search word one by one to find out, what are the top 3 words in the trial tree. So insert trial root, and then this would be string product. So the root itself will be repeatedly used, and then we don't want to touch it, so we create a copy. It's called node, and then we are traverse the whole entire character from the product. So we want to make sure is the current C at the children is defined or not. So this is a trick. We definitely want to define this, because the constructor already defined the first level. You want to define your next level, right? So I will do this: if the node at children C minus A is equal to null, I'm defining my level for child, and afterward I can actually move on. Not equal to node.children C minus A. I move on. So when you define, you already know this is one of the character you're going to use, and then you, at this moment of time, you can add a word into the current character. So I will say node.children.add. You can do offer or add, doesn't matter. What you need to do is you add a product. So once you add it here, and then you can do a collection.sort the whole entire linked list, and then if the size is more than 3, then you want to remove the last one, because this is lexicographically order, right? So A to Z order, right? So the last one is the one that you don't need it. So node suggestion that pull last. Yeah, definitely you can do this for enhancement, but think about it, every 3 items you will remove it. So technically this is a constant pretty much. So once you have this, and then this is everything you need to do. And then for the search, I'm doing a search, and you need to return a list of list string, and then search trial root string search word, and the same thing, you're going to have the root that you need to define, or you can repeat it using it. It doesn't matter, because this is going to be a last function in this method. Alright, let me remove it. It doesn't, you don't need it technically. So I declare my result. Okay, now I just literally need to traverse the trial for my current search word. So I'm doing this for char C search word to char array, and then what I need to do is I want to make sure if the current root at this level is not equal to null. So if this is not equal to null, I want to point at the address for this current character. So root equal to root.children C minus A. So once I point at this, I know I can get the suggestion, right? But if the root is equal to null, right? There are two kind of scenarios. When you have all of the list of string in the product, that doesn't happen. That doesn't have associated with the search word. Then you still remain the root equal to null, right? So if the root is not equal to null, you point at the next character, and you're going to add a surjection into the result. So if this is not null, then you just add new array list root.surjection. But what happens if this is null? Then you can just add an empty array list. So this is pretty much what you need to do. So children, I think it's like no, this is surjection. So you want to add your word into the linked list, right? So there should be one more search word to chart array. Should be it. Alright, so this is the whole entire solution. So let's talk about the time and space. So time, this is all of p, you can say all of n, and inside the insert function you traverse every single character for every single word. So this is all of the maximum length of the product, because you already traverse all of p, and you can say all of n, and then you do the sorting every single time. So I would say all of p times all of n, and I would say this is constant. But if you do want to say not a constant, you can say x log x. X represents size of 3. I mean you're sorting the word, the list of string 3 at a time, or even 4, but it should be constant. So this will be the whole entire time, and definitely this is another time, but this is straightforward, all of s, and then you just move on your trial tree. So this one will be definitely smaller than this one. And then for the space, this is going to be the space, and this will be the space. The worst case, you add every single word in here in the tree, right? So it's going to be all of what? All of p for every single for every single children. So time and space is pretty straightforward, and I'll see you later. Bye.